So we shall continue then.
Okay, sir.
I'll share the screen.
Yes,
Yeah.
sir.
Any question till now?
No,
अभी
sir.
तक जो भी कवर किया उसने. Fine. So this is the next part, overview of NumPy. Right. So what is NumPy? NumPy is actually the full form, short form of numerical Python. Numerical Python is a library which is created in Python, and especially it is optimized for the fast execution of numerical data specifically. So where do we need this? Most of the times what happens even in machine learning applications or most of the practical applications when we learn model or when we see the data. So maximum the features which are available in data are in numerical form, right? And even if there are some other form like in terms of variables or names, that is the data which is available in the form of text, right? Like for example, gender, male and female, or country name, right? Or city name, etc. They are having text in that. But otherwise, most of the features which are available in data exist in numerical form. So whenever we learn some models in machine learning or data science application, it's better to operate on those numbers in efficient manner, right? In Python, we saw that the sequence of numbers or the collection of numbers can be stored in different forms like lists, tuples, or even dictionaries we saw. But when we work with them and when the size of data is large, it becomes difficult to run or execute a program in shorter duration. So it will take more time to execute the program if there are like thousands or millions or billions of entries. In that case, it's always better to optimize the code in the background. And that is done in this library, in this package. So its source code is available. It's free for the public. It's started by Travis Oliphant in 2005, and it's available in GitHub openly for the public. So you can go through the code if you want what exactly it's doing in the background to understand it. But for us, it's not required. We'll just understand the application of this code and this library for our purpose. Okay. Right. So basically, in case of NumPy, we work on arrays instead of single entry, single numbers, because we want to work on large collection of numbers. So those collection of numbers can be represented in terms of arrays. Array is what? Array is the sequence of numbers represented in the form of collection, and it can be represented in terms of just one single list or two-dimensional list, like we call it as array. In C, C++ or Java, there also we call it as array, but in Python generally we use them as lists or other collection types. So in case of NumPy, we retain those names like arrays. So array can be of multiple dimensions, one-dimensional, two-dimensional, three-dimensional, or even higher dimensional arrays. We'll see later what all those dimensions means. For now, we can see that the application of this NumPy library is spread over multiple domains, specifically like linear algebra, which is the mathematical branch, and Fourier transform and matrices. So all these things can be performed or can be studied in NumPy, right, using NumPy library. So just excuse me for my cough somewhere in between. Okay. So now, why to use this NumPy library? Let's understand this. The first and most important thing is it's faster. It's faster than the list and other data types that we are studying in Python. So when we are working with smaller data, smaller amount of data, the time doesn't matter for us. But as the data size increases, when it goes to millions or billions of rows or and data, in that case, the running time may go into a few minutes or sometimes in few hours also. So we always want to reduce that time. Let's say, for example, to for the execution of some program, it takes around 1 hour in normal Python using lists and all those things. Then in case of the program which is implemented using NumPy, the same program, if we convert using NumPy, then that execution time may get reduced to even 2 minutes or 1 minute, right? So a drastic reduction in execution time can happen using this NumPy library. That's why it is very important to understand and try to use this NumPy library in the different applications. An array consumes less memory and it is convenient to use. So as compared to list, this array which is used in NumPy consumes less amount of memory. Now why it is so? The first important thing to understand is the list or other collections in Python that we have studied are applicable in general for all the objects. That means what in a one particular list, we can have different types of objects. And that's why it is object-based list, object-based memory. So depending upon data type, it may take different sizes and also it will take a little larger time so that it can understand what data type each of the element has and accordingly perform some operations on it. But here in case of NumPy, we generally always know that the data type can be either integer or float or boolean, right? So considering or defining that type of data for an array, it's easy for the code to consider the single type of data and then perform operations on it. So no need to check what type of data is present. So that way there is a time reduction in the execution during the execution. And also because there is little less memory required for the storing of a particular integer or float number as compared to the object, because object consumes larger memory to store little more information about the class and object, right? So it's always less amount of memory which is required for this NumPy implementation or NumPy arrays. The next important point is NumPy uses much less memory to store data and it provides mechanism of specifying the data type. So we can always specify the data type, what type of data we want or what type of data will be there. It can be integer or float or string. If we want, we can mention that data type. So it's flexible. It's not that it is fixed. So we can decide that data type. It allows code to be optimized even further to heavy tasks involved in the machine learning applications. So that's what we have discussed earlier. Now, how to use this NumPy library in our code? For its usage, first we need to install it, right? After installing Python, we can install this library using this command, pip install NumPy. For this, we need to go to command line, just open command line and execute this command, right? Once you execute this command, NumPy library will be implemented and then you can use it in your code. And if you are working on or working with the notebook here, then in that case, you can use the command like exclamation mark pip install NumPy, right? So suppose here I can write this command and then execute it. Simply press Control Enter. So it will execute in the background. So this star here, it is showing star. Star means the command is under execution, right? So it is getting executed, right? So it's not right. It is fine. Already satisfied. So what it is saying, requirement already satisfied means NumPy is already installed for me. So for me, it is already installed. That's why it is directly showing this. If it is not installed for you, then it will install all the background packages which are required for NumPy. Right, so this is how we can install the NumPy library. Now, once it is installed, I'll just remove this for now. Once it is installed, we can proceed for its usage in our code. So first, let's understand how to create arrays. Right? Array is what? Array is the collection of elements. So just like list we saw in Python, here also it is represented in the similar fashion, just like list. In the square bracket, we have different elements separated by comma. So if we have single list, then that is considered as one dimensional array. One dimensional array means, like, suppose it is having only row, right? There are no multiple columns element, and there are no multiple elements in each column also. Right? If there are multiple rows available, then that becomes two-dimensional array. Right? We'll go to that later. First, let's understand how to create an array in Num. So to create an array, there are again multiple methods. The first and basic method is using numpy.array. In that, first element is the raw data. Now, this raw data can be in the form of list or tuple or anything. For now, we'll be following the basic approach of providing list in this. So once we provide a list, that will be converted to array using NumPy library. Now here we can mention the data type also, what type of data we are giving. And if we are initializing with the default values like zeros and ones, then what type of data that should be considered? It can be considered as integer or it can be considered as float. Accordingly, we can mention the data type. Now there are multiple other parameters. Those parameters are not required for now. Whenever they are required, we'll discuss it later, but these are very much rarely required in any application. So we can just skip it for now. So these two are important for us. First, the object, which is like raw data, and second is data type, what data type we need to mention there, right? Now, let's see the examples. First, to use this NumPy library, we will be importing the NumPy library, like using import NumPy. Now, again, I said in the previous sessions that we can use an alias name, alias here. So for NumPy, it's a common practice to use NP. So NP stands for NumPy. So using this NP, now we will be calling different methods which are available in NumPy. Now to understand which version is installed for my machine, for my desktop or laptop, we can use this particular command, np dot double underscore version double underscore. So if we just type this and execute, I can see this is the version of NumPy which is installed in my laptop. So this is the latest version actually, I can see, which is installed here. There are multiple updates in different versions, so that we should understand which type of which version is installed my machine and which features are available in that particular version. Now let's create an array. The first simple method to create an array is np.array. That's what we saw this as a syntax, numpy.array. So instead of numpy, we'll be using np now. So np.array, and the data that we are putting in the form of raw data. So it's like a list that we are providing here, 1, 2, 3, 4. There are 4 elements in this list. So now because there is single list here, I can say this is a one-dimensional array. So whichever array is getting created using NumPy library, that will be one-dimensional array. I can print that array. We will see the output later. I can print that array, and to see the dimensions. Now because there is only one single row, so this is nothing but the one-dimensional array. So when I print this a dot n dimension, it will show the dimensions of that particular array. Then shape of a. Shape means what? Shape means how many rows, how many columns, and what all dimensions. So whichever dimensions are there, how many number of values or number of uh, possible columns and rows are there in that particular dimensions will be indicated in this shape. Like this is only one dimensional array, so this n dimension will retrieve the one, it will return the one, and shape will return how many rows and how many columns are there, right? So we'll see that. And also size means total size of this array. So there are 4 elements in total, so it will indicate the 4 size there. Let's see the output here once we execute. So this is the array 1, 2, 3, 4. Dimensions of a 1 because it is one dimensional. Shape of a because one dimensional. It is only indicating how many columns are present there. So there are 4 columns, so it is showing us 4 comma nothing, right? 4 comma nothing means there are only 4 elements in that particular one dimensional array. And size of A is 4. There are only 4 elements, so it is indicating 4 as a size. Now let's see the two-dimensional array, right? How to create two-dimensional array. So here you can see, to represent two-dimensional array, again we are using a square bracket. Understand? Inside square bracket, we will be using this list. So this is one list, then this is another list 5, 6, 7, 8, and this is third list 9, 10, 11, 12. So each list is having equal number of elements. So all these three lists have 4 elements each. So each of these actually represents one row in that particular sequence. So there are three number of rows I can say, and in each row there are 4 elements. So I can consider there are 4 columns in total, right? If I just represent it like this, you can observe this is like a matrix. Okay, this is like a matrix. Yeah. So there are 3 rows and there are 4 columns. So number of rows and number of columns whichever are available, accordingly, the dimensions of this array becomes 2, because there are horizontal rows and vertical columns. So two-dimensional array we can say. So this is 2D array with 3 rows and 4 columns. I can print that array. Now the dimensions of A are 2, right? Because there are rows as well as columns. So each row and column represent one dimension each. So there are a total of 2 dimensions. Shape. Shape means how many rows and how many columns are there. So in general, we don't say them as row and column, but instead it's always better to represent or consider them as dimension 1 and dimension 2. So how many elements are there in dimension 1, how many elements are there in dimension 2, that actually is written by this shape. So if I execute this part, you will see this is the array that we have initiated. The dimensions are 2 and shape of this is 3 and 4. 3 and 4 means what? In first dimension, that is like row, there are 3 rows I can see, 1, 2 and 3. And for that it is giving the first dimension as 3, first shape of 3. And the second, in the second dimension there are 4 elements in each row, so that 4 is indicated as the second shape here. So shape actually gives the number of elements in each dimension, and size is 12. So total number of elements here are 12. 4 multiplied by 3, total of 12 elements. So that is the size. So these are the 3 basic commands that we can execute on NumPy array. So we have initiated this array as np.array and giving some basic data in it. So remember, for two-dimensional array, we need to mention 2 square brackets. In the external square bracket, that is acting as the main container for this data, and inside that there are 3 different lists separated by comma, right? So that's why it is becoming two-dimensional array. Then on each array we can uh, check the basic information like n dimensional. Ndim will give us the dimensions, shape will give us the number of elements in each dimension, and size gives the actual total number of elements present in that particular array. These are the basic parameters that we can see. Now, creating array from subclasses. Subclasses means what? The classes which are derived from NumPy array, right? We know how to derive or how to use inheritance concept in the classes, right? So in the similar fashion, array is one class and there are multiple other subclasses. The one of them is matrix. So let's see the example of matrix as a subclass of array. So what we do, np.matrix, np.mat. So it initializes its matrix using these values. So values, how we are representing the values? The values are separated by space, you can see. So this is given in one particular string and data is retrieved from the string. How data is retrieved? It is saying that each row is separated by this semicolon. Remember, row is separated by semicolon and column is separated by space. So 1 space 2, that means 1 and 2 are the 2 elements in first row. Then semicolon means go to the next row. 3 and 4 are 2 elements in the second row. So that's how it is taking 2 rows and 2 columns for this particular matrix. And that we are supplying as input to this array. So NumPy is creating an array using this matrix. But when this matrix is given as input to array, that matrix is getting converted to array type. We can see that type later here. So array A is printed. So I can see array A is two-dimensional array, 1, 2, 3, 4, 2 rows and 2 columns. And its type, when I print, the type of array A is numpy.nd array. ND array means n-dimensional array, general. So here it is two-dimensional array. So basically I can see even if matrix is given as the input, it is getting converted to array type, ND array type. Now, if you want that to keep the data type as matrix and don't want to convert that to array, in that case, we can use this parameter called sub-ok. Okay, it's like sub-ok. So here I can say specify this sub-ok if we want a subclass or base class type array, right? So here we want matrix as the data type. So we can mention that as true. Only we need to mention a true or false. The data type will be taken as we are mentioning here, right? So whatever data type we mention here, accordingly that will be retained. So here, because we are mentioning this sub OK as true, so it will keep that matrix type as matrix type. It won't convert that to array type. So now here, if I print array B and its type, we can see array B is printed as same as earlier 1, 2, 3, 4, and its type is now matrix, numpy.matrix. That's how we can retain the data type there, right? Or subclass type. Next, now while creating an array, we can also create an empty array. Like there should not be any values. That's what we can mention. Or there will be random values in general, right? Remember. So an empty array. So to create an empty array, what we do? We use np.empty. This is the command. And inside that we can give two parameters, shape and data type. Shape means how many rows, how many columns, or if there are multiple dimensions, how many elements should be in each dimensions, that should be mentioned in the shape. And shape should be given in the form of list here, right? So this is the list in which each number indicates how many elements should be there in that particular dimension. So here I am mentioning 2, 2. 2, 2 means two number of elements in first dimension and two elements in second dimension. So there are 2 rows and 2 columns, a total of 4 elements I will be having in that particular array. And what is data type I am mentioning? Data type is integer. So by default, it will create an array of 2 by 2 dimensions, each of having an integer value, and the value will be random. By default, np.empty will create an array with random values, right? So here array will be created with random values. In a similar fashion, we can have different dimensions also. np.empty 2, 3. So this will create 2 by 3 array of data type float. Type can be given as we wish, as we need. Then next, I'm creating a 3 by 2 array, 3 by 2 array of strings. Again, by default, strings will be empty here. By default, float will be either 0 or some random values. So either of them, right? And finally, I'm also creating a array which is of size 2 by 4, and the data type is Boolean. So let's see how these arrays are created randomly. First one is of integer of 2 by 2 size. So here I can see the array, right? If I execute it again, you can see here. So when we execute again and again, we can see there are different data types that will be decided by system. Now, whatever data is being filled up in this particular array, that will be random data, right? For now, it is 1, 2, 3, 4. Earlier, it was something different. Some positive or negative numbers also possible, right? So it's not fixed that what data will be filled in there. It depends on machine and when we execute that. So there is no fixed rule for that. The next, for float, when we have created this 2 by 3 array of float, we can see this is the 2 by 3 array of float, and this is the result. So all the values are initiated with 0 point. So 0 point something means 0 point. It is just initializing with that 0 value, and also it is mentioning that it is having a decimal place. So the number is float there. It's not integer. Next, the array of strings. We have created array of strings of 3 by 2 dimensions. So 3 rows and 2 columns. And here it is initializing with empty strings. You can see there are three rows and 2 columns with each element being an empty string. And finally, one array of Boolean type. Again, these Boolean values are random. Some of them are true, some of them are false. So accordingly here you can say 2 by 4 array. There are 2 rows and 4 columns each. So randomly it is taking false element for each one, right? So again, it's not fixed. It can be anything. It's random in general. Whatever values system decides, those values will be stored in the array. So this is how we can initialize different data type arrays, integer, float, string, and boolean, and accordingly the array will be created. Next, another method to create array is using zeros and ones and identity matrix. So suppose there is some situation where we want to create an array where all the entries are zeros or all the entries are ones. It is fixed. In that case, we can directly use the zeros or ones functions which are given by this library. So what is the syntax? It is simply like this: np dot zeros, in bracket we mention shape and data type, just like earlier we mentioned for array, right? np dot empty, we have mentioned the shape and data type. In the similar manner here also, np dot zeros, mentioning the shape and data type, will return an array of zeros. Instead of zeros, if we use ones, then all the elements which are there in the array are having values 1, and data type can be integer or float there. Then if we want to create an identity matrix, what is identity matrix? Identity matrix is the matrix where all the diagonal elements are 1, right? So such can be created using this EYE function, which is present in NumPy. So let's say some examples here. So zeros array, I am creating 2 by 2 zeros array with data type of integer. Then ones array of 3 by 2, data type again integer, I am keeping that as integer only. And an identity matrix of size 4. Now here remember, we are giving only one particular integer input, right? In case of identity matrix, the first element is only one integer. So that itself is taken as dimension, which is same for all the uh, is a number of elements in each dimension, right? So we are mentioning here 4, so it will create a matrix of 4 by 4. So 4 rows and 4 columns with diagonal element at 1. So that is the identity matrix here. So if I just print them, you can see first all the elements are 0, second using ones all the elements are 1, and lastly an identity matrix where the column elements are 1 and all remaining elements are 0. So that is how we can create identity matrix. Similarly, we can create upper triangular, lower triangular arrays using these commands like triangular array, triangular lower, triangular upper. So these are the syntax for that. np dot try. Tri means triangular array. And again, we can mention the dimensions like how many rows and how many columns we want. And accordingly, it will be created. And third is the position of uh, position of diagonal from where the number of zeros will be starting or number of ones will be starting, right? That is the indication. So basically the first diagonal, main diagonal, is having position 0. Then from 0, the dimensions above that, remember we are giving the dimensions as per the column, right? Sorry, as per the diagonal. The diagonal, main diagonal, from left top corner to right bottom corner, it's the 0th diagonal, I can say. Then one diagonal above, or one diagonal above this main diagonal, is mentioned as first. Then above that second, above that third, and so on. And below, in the reverse direction, it's -1, -2, -3, and so on. So diagonals are given numbers here, positions here. So I am giving this 2. It is mentioning that 2 means what? Above 2 there will be zeros, right? We'll see that how it will change. If I execute this, this is what we are getting. So instead of 2, let us suppose I'll give 1. So you can observe now, right? From 0, this is the main diagonal 0, and then next one is 1. So above 1, we will be getting all zeros. Above 1, we'll be getting all zeros. Now let's suppose if I mention -1, so you can see now main diagonal is 0, and below that it is -1. So above minus 1, all elements are 0, right? Are you getting this point? How these zeros and ones are decided,
Yes, sir.
right? So this third parameter actually indicate the diagonal. Which diagonal? Main diagonal is 0. Above that, then one, first diagonal, second diagonal, third diagonal, and so on. And below main diagonal, there are minus 1, minus 2, minus 3. So this is the diagonal position actually, you can say. And above that diagonal position will be all zeros, and below that diagonal position will be all ones. So that is how this triangular matrix gets created. The next, lower triangular matrix. This is TRIL. L stands for lower triangular, and TRIU stands for upper triangular matrix. So what is lower triangular matrix? In lower triangular matrix, lower triangular elements or the elements which are below the diagonal are non-zero, right? And in upper triangular matrix, the elements which are above the main diagonal are non-zero. That is the general concept, right? Number of elements whichever are there. So which elements are 0, accordingly it will be a lower triangular or upper triangular. So here what I am doing, I am initializing an array with some elements. So this is two-dimensional array, right? This is, I am giving this as an input, and also I am mentioning that in lower triangular matrix, from which position I want this to be a lower triangle. So again here I am mentioning as position, right? If I mention this as 0, which is default, in that case, above the main diagonal, all the elements above the main diagonal will be 0, and diagonal and below diagonal can be non-zero elements. This is the default 0. If I mention this as 1, then it will go one diagonal above, right? One diagonal above. So above main diagonal, there is this first diagonal, then above first diagonal, there will be all 0 entries. If I mention this as minus 1, right? If I mention this as minus 1, then all the entries which are above minus 1 diagonal, those entries will be 0. That is how this position of diagonal is mentioned as a second parameter this to this TRIL. Similarly, TIR upper triangular matrix, we can mention the raw matrix here, and the position of diagonal below which there will be 0 entries, right? So here I am mentioning in minus 1. So below minus 1, there will be 0 entries in upper triangular matrix. So that is how we can get the different types of triangular matrix: upper triangular, lower triangular, general triangular. I hope you understood here.
Yes, sir.
Okay. Right. So now let's proceed to next, array manipulations. Now, once we have created arrays, what all different operations we can perform on those array? Let's understand them one by one. Now, these are very important. Different operations whichever we are performing here, this will be required for data handling in case of data science, right? Whenever we read some data, we want to remove some of the columns, we want to remove some of the rows, or we want to replicate them, duplicate them, or we want to make them 0, we want to make them we have to read non-zero entries, and there are multiple operations that we would be like would like to do in future. So most of those are covered here. So we'll be saying what all operations we can perform on them. The first one is indexing and slicing of one-dimensional array. Slicing means what? Taking sub part of array, right? How to index the array? Index means what? How to retrieve elements using positions. That is the indexing part. And slicing means taking sub part of that array, some of the rows or some of the columns or some of the multiple dimensions that can be retrieved using the slicing concept. So we'll see them one by one. The first, for one-dimensional array. If we have one-dimensional array, then to mention the indexing, there are three possible entries. One is start, another is end, and next one is step. So these three entries we can mention. Step is optional. We can only mention start and end, that is also enough. Step is optional. Also, there are default values for the start and end. Default value for start is 0. Default value for end is the length of that particular array. And step size is 1 by default. So if you want to give different values, then we have to specifically mention them. Otherwise, the default values will be given, will be taken. Let's suppose we create an array here. Now, this is one method of using for loop in case of list. So in Python, we can create a list using for loop like this. This is a shorthand notation for loop. So what it is actually doing, it's like this. Let's suppose we have some array as A, and then what we are doing, we are doing a for loop for I in range 10. For I in range 10, A dot append I square. So that is what it is actually doing, right? If I do this particular operation, it will create an array with all the entries from 0 to 9. Remember, range 10 actually has elements from 0 to 9, and square them and store them as a list. So same thing is mentioned as a shorthand notation in this fashion. So this is the feature of Python. In case of Python, we can initialize a list using this approach. So understand what all elements, how we are mentioning. So this I square, whatever operation we want to do, that is actually mentioned here. We are doing this A dot append. So that is actually by default mentioned like this. In square bracket, we are using this entry, right? So it's like this. What we want to do, we want to create an array with square of I. Now what is I? I is a variable which is ranging from 0 to 9 here. So we can say it's I square, element is I square for I in the range 10, right? So that's how we can read this. And accordingly, an array will be created here. Just comment this part for now. So this array will be created where all the entries are square of numbers from 0 to 9. Now if I execute this, we can see the entries are 0, 1, 4, 9, 16, 25 up to 81. So square of 9 is 81 at the end. So that is the array which we have created. Now this is the list, actually the first part which we have created. This is a list. It is not an array, right? This is the Python variable. Now that list is converted to array using NP array. Now it is converted to array, and by default, whatever is the data type uh, of those elements in the original list, that data type will be retained by this array, NumPy array. So now it is converted to array, and we can print the array. So it is printed like this. Next, suppose to retrieve element, just like list, we use the position or indexing. Similar fashion, here we can use the indexing or positions to retrieve different elements, right? So like A of 4 means what? Actually, it is the fifth element here, 0, 1, 2, 3, 4. So A of 4 is 16. Then A of minus 2. So at the end, it is minus 1. Then it is minus 2. So A of minus 2 is 64. That's how these elements are retrieved. It is similar to the indexing of list that we are used in the Python. In a similar fashion, we can give the range of indices, right? The range of indices here, let's suppose if I mention 2 to 5, right? So this is a slicing part, right? So if we mention this range, then that is a slicing of array. So taking sub part of array. We are not taking only single element, but a range of elements. So let's say here 2 colon 5. 2 colon 5 means what? We are starting from 2 and going up to 5 minus 1. 5 minus is 1 is 4. So 2, 3, 4. These elements are retrieved. So 2, 3, 4 means what? This is 0, 1, 2, 3, and 4. 2, 3, 4 are nothing but 4, 9, and 16 elements. So these elements are retrieved, and that is written as a different array, right? So here you can see it is returning that array of 4, 9, and 16 elements. So this is the slicing of array. Remember, in this case, whenever we mention these two values from where to where we want to go, the left value and right value should be mentioned such that the right value should be ahead of left value in array positions, right? So we cannot mention 5 colon 2, right? Here, if I mention 5 colon 2, what will happen? It's like 5, 6, 7, 8, 9, right? So positions are always increasing from 5. So it will never go to 2. It's like a reverse. In that case, it will return the empty array. If I execute this part, it will return empty array, you can see, right? So remember, to get elements properly, we need to mention the positions accordingly, so that left position and right positions are actually towards left and right in the list. Right? Let's suppose if I mention 1 comma minus 3. Now 1 comma minus 3 also are the positions or indices. So one position means here for this one element I can say, right? For this one we have one position. Then minus 3, where is minus 3? This 81 is at minus 1, 64 is at minus 2, and 49 is at minus 3. So I can see this minus 3 is towards the right of this one position. So I can say this is also a valid kind of positioning or indexing. So this is valid and it will return the result starting from 1 to 1 minus that 49, that is up to 36. So from 1 to 36, it has returned that particular array. So this is how we can also use the negative indexing. Right. Okay, so now also one more thing here I given as the example. When the index of this first value is to the right of second value, in that case it will return the empty array. Right? That's why it is also written in empty array. The third parameter is of step. So here I can see the start, end, and step. So if step is not mentioned, that is optional. If step is not mentioned, by default step is taken as 1. So here the elements from 1 to 6 will be taken, but now step is mentioned as 2. So it will start from 1, then it will have gap of 1, right? So 1, then 3, then 5, and then 7. But 7 is not included here. It will go only up to 6. So 5 will be the last element. So accordingly, if I take those elements here, I can see 1, 3, and 5. So their squares are present here. Right? 1, 3, and 5 squares. That is this original array, and the elements of those array are mentioned here. In the same fashion, we can see 9 colon 2 and minus 2. Now see the indexing position. This is reverse. Right? The first number is greater than second number. So start is greater than end. In this case, the step is given as minus 2. That's why it will work. If step is given as positive, then it won't work, because step is given as negative. So what it will do, it will start from now 9, then it will use two step size of minus 2. So 9 minus 2, 7, 7 minus 2, 5, 5 minus 2, 3, 3 minus 2, 1. So 1 it will not take because 2 is the end. So only up to 3 it will go with the step size of minus 2. So likewise, in the reverse fashion, we can take the elements, right? If we want to take the elements in reverse manner, then we can use such kind of negative step size. Either it can be minus 1, minus 2, minus 3, whichever we want. Accordingly, we can mention the step size. Next, array 3, 3 colon. Remember, there are 2 colons in general. There are 2 colons. Before first colon, we have starting position. In between 2 colons, we have ending position. And after second colon, we have step size. Step size is optional. So the second colon mention is also optional. If by default we mention only one colon, then that will be in between start and end. So here what I am doing, array 3 colon. 3 colon means what? We should start at 3 and end is not mentioned. End is not mentioned means by default it will go to the end of that particular array or length of that array. So that's why here I can see the result is starting from 3 square and it is going all up to 9 square. Right? So it is taking complete array ahead of this 3 square. Similarly, I can mention negative also. Negative means what? From the right side. So 81 is minus 1, 64 is minus 2, 49 is minus 3. So from minus 3 to end, it will go. So minus 3 column means minus 3 to end. So 49, 64, 81. Like this, it retrieve those values. Now in next case, we have mentioned the second parameter. Remember, in front of first column, we have end. Start is not mentioned. So by default, start is taken as 0. And here end we are mentioning as 3. So now elements from 0 to 3 are taken. 3 minus 1 actually, right? 3 minus 1 means 2. So 0, 1 and 2, square of those elements are retrieved here. In a similar manner, we have negative end. Okay. So here we are giving the negative index. So we are mentioning the end here. End is -3. -3 means what? It's 49 elements. So before 49, all the elements starting from 0 go up to 36. That's what we are giving here. So starting from 0, it is going up to 36. That is this minus. Again, the next part, like we are not giving first two parameters now. Now start and end are not mentioned. So what we'll be doing? We'll be going from 0 to the length of array by default. And the step size only we are mentioning 3. So that's why we are going with the jump of 3 elements. Starting with 0, then 0 plus 3 is 3 square 9, 3 plus 3 is 6, 6 square 36, and 6 plus 3 is 9, 9 square 81. So up to these elements we have uh, retrieved the elements. In the similar manner, the third step size can be negative without mentioning start and end. If we just give the step size as -1, then by default array will be reversed. You can see the array is simply reversed here. So this is one technique we can say to reverse an array. Whichever is given array, that can be reversed using only last entry mentioned as -1, step size mentioned as -1. Now getting specific element, here what we did, inside this particular square brackets, we have mentioned three parameters: start, end, and step. But instead of that, suppose we give one list in that. Okay, inside square bracket, we are giving one particular list. Then it is taken as those individual element positions. So 159 means what? I want to take elements which are at position 1, 5, and 9 only. So we are not giving any start, we are not giving any end, or we are not giving any step size here. We are specifically mentioning the positions only. So it is retrieving the elements at those positions. So 1, 1, 5, 9. So their squares are 125 and 81. Again, we can mention any sequence here. Sequence doesn't matter. We can give on first as 5, then let's say as 3, and so on. So anything is okay. Accordingly, those elements will be retrieved. So 25, 9, and 81. Understood? So these are different positions. Even for 9 is we can give the -1 part also. So that will be 81 again. Right? So negative indexing is also possible. I can give -2, so it will be 64. Right? Positive or negative index, whatever index is, whatever may the sequence we want, we can mention, and accordingly array will be written. I hope you understood the indexing part till now. Let me know if you have any question.
Yes, sir. No problem.
Clear everything?
Yes, sir.
Okay. Fine. So this is about one-dimensional array. If we want to define and retrieve the elements, so this is how we can do the indexing of one-dimensional array. Now let's
When you
go to the two-dimensional.
last member n minus 1.
Hmm.
Okay.
Last one is n-1. N means what? End. Right? We are giving here start, end, and step size. These three parameters are given. So it will start from start, but it will go up to end -1. Right? Because actually position start from 0. Right? Generally position start from 0. That's why it is going to end -1 only. Right. Now let's understand the two-dimensional arrays. Right? In two-dimensional array, we have multiple rows and columns. So accordingly, let's suppose here for two-dimensional array, we need to mention multiple lists which are separated by comma. So I'm giving here three lists: 1, 2, 3, 4, 10, 20, 30, 40, and 100, 200, 300, 400. So these are three lists which are separated by comma in between. And all those three lists are again enclosed inside one square bracket. Right? So this is outer square bracket inside which we are giving three lists separated by comma. So by this method, we can create two-dimensional array. So this is two-dimensional list actually. Now that list is converted to two-dimensional array using NumPy array function. So NumPy array and this two-dimensional list is given as an input. So that has converted to array now. Now again, indexing on two-dimensional array can be done in two different ways. One way is mentioning the row and column here. So let's suppose this is array ARR. So array of 2 comma 3, that means row number 2 and column number 3. Row number 2 and column number 3, that elements will be retrieved. So what is row number 2 here? Row number 2 is this 10, 20, 30, 40. In that, what is column number 3? Column number 3 is, sorry, row number 2 is this. We start from 0, right? We start from 0. So this is 0th row, then this is first row, and this is second row. So row number 2 is this third list, and inside that we want number 3 column. Number 3 column is 0, 1, 2, 3. So element 400. We are choosing this element 400 using array 2 comma 3. So like this, we can mention the positions just separated by comma. Another alternate method is give different dimensions in different square brackets. So array of 2 comma 3. So second row and third column. Like this also we can mention the indexes. So both of these will result into same output 400 in both the cases. Also we can give the range. Let's suppose we want 1 to 2 rows and 2 to 3 columns, or whatever may be the number of columns and rows we can mention here. So here let's say 1 to 2. 1 to 2 means what? Actually it goes from 1 to 2 minus 1. 2 minus 1 is 1 itself. So it is taking only one entry here, right? Also 2 to 3. 2 to 3 means what? 2 to 3 minus 1. 3 minus 1 is 2 only. So that's why it is giving only one column. So only one row and only one column. Which row? First. Which column? Second. So first row and second column. This is first row and the second column is this 30. So that's why it is returning this 30, right? So this is how we can get this sub array, retrieving sub array. In first case, what we did, we retrieved a single element. Here what we are doing, we are retrieving multiple elements mentioning this colon part, right? Mentioning column will return the multiple elements, but because we are mentioning the indices here as 1, 2 and 2, 3, so it is returning only single value. If I mention, let's say 2 comma 1 3 here, 1 3 column, then what will happen? 1 to 2, that means it will take only this first row. Then 1 to 3 columns, that means it will go from 20, 30 and 40. 20 and 30, actually 3 minus 2, there it will stop. So 20 and 30 it should return. So I can see here, if I execute this, it is returning 20 and 30, right? So whatever maybe the columns and rows will be mentioned here using the colon. So start and end will be taken there in those respective dimensions. So this is the position for first dimension and this is the position for second dimension. In a similar manner here also another example from 1, 3 and 0, 2. Like here we are taking first and second row and 0 and first column. First and second row means these two rows. Sorry, first and second row means these two. And 0 and first column means the first two columns here. So 10, 20 and 100, 200. That will be written here. So 10, 20 and 100, 200 as a return. Next example, like in the first dimension, if we just mention colon, just mentioning colon means what? Start is 0 and end is length of that particular dimension. So first dimension is for rows. So it will take all the 3 rows which we have given here. And 1 to 3 means there are 2 columns we are taking. So I can see here, all the 3 rows are taken, but only 2 columns are taken, right? So that is how, if you want to take all the rows or all the columns, then just mention colon there, that will be enough, right? The next part here, I am taking all the columns, but only 0 and 1 rows, right? 0 to 2 means 0 and 1. So first 2 rows I can see, but all the columns are present in those rows. That is how we can take all the rows or all the columns here. Again, if I mention both as colon, that it simply means take all the rows and all the columns. So it is equivalent to simply taking complete array, right? In case of 2-dimensional array, it is taking complete array here. Again, step size can be mentioned here if we mention 2 colons. So considering 2 colons, the first parameter is start, second parameter is end, and third parameter is step. We know their default values. Start has default value 0, end has default value as length of particular dimension, and third step size is by default 1. And so if we want to change any of them, we can mention them and accordingly the elements will be retrieved. So what we are doing here, here I'm taking the step size 2, and here I'm taking the step size -1. -1 means what? Reverse, right? It is reversing those elements. So here I can see instead of 1, 2, 3, 4, it is taking as 4, 3, 2, 1, because we are reversing this using -1 step size. Also here, instead of 100, 200, 300, 400, it is taking reverse 4, 3, 2, and 100, right? Like this. In a similar manner, we can give other different uh, entries as start, end, and step size, and accordingly the elements will be retrieved. Right? So there are different. Also, specifically, if you want particular rows and particular columns only, then they can be mentioned using lists. So instead of colon, we can simply give list here, and those lists will be taken as specific rows and columns, and those elements will be retrieved here, right? So here I am giving second row and first row. Take second row and first row, then zeroth column and third column, like this. Zeroth column and third column. So it is returning that 100 and 400, right? Next. Okay. So here once more understand this. 2, 1 means what? 2, 1 means second row and first column actually. Okay. Let me correct it. 2, 1 means what? Second row and first column. Which is second row and first column? Here I can see. This is second row and first column is this. Wait. This is row and this is column. Let me write it here. Okay. This first entry is corresponding to row and second entry is corresponding to column. Right. Now what we are doing here, I am taking second row and zeroth column. Second row and zeroth column, and second entry is first row and third column. Like this it is taking. Okay, understand it clearly. Second row and zeroth column. What is second row? Second row and zeroth column is 100. Second entry is first row and third column. First row means this row and third column is this 40. So first element we got as 100, second element we got as 40. And accordingly, these elements are written. So first entries which are given in the form of list, those are corresponding to rows. And the second entries given as list are corresponding to the column. So sequentially, this will be grouped like number of rows and columns, number of rows and columns, and accordingly the elements will be retrieved. So those specific rows and specific columns are considered for retrieving the elements. Again, in the similar manner, using colon, we can mention the start or end, and accordingly the arrays will be returning those particular elements here. Right? I hope you understood this indexing part for 2D arrays. Let me know if you have any doubt. Is this all clear? So let's go ahead now. If we want to copy one array into another, right? Copy one array into another, then there is one function called copy2. So numpy.copy2, then destination and source. From which array to which array we want to copy, accordingly we can mention here. So those elements will be copied here. Let's see, suppose we create two arrays here, one zeros array, one ones array. Now remember here, the array size should be same. Okay. So we are having 2 by 2 dimension and 2 by 2 dimensional arrays of zeros and ones. Now what we are doing, copy to zero array and ones array. So ones array is now source and zero array is now destination. So all the elements from ones array will be copied to zeros array. That means what? Now zeros array will contain all the entries of 1, right? Earlier it was all zeros. Now it will be all ones. So you can see now if I execute this, we'll get this. Initially the array of 0 is this, then array of ones is this. And after copying, we get all the integers 1 in case of 0 array also. So there is a simple copy to function. Another method, like there are two techniques to copy this, like view and copy, we say them. View means what? view is actually just pointing to the original array. It's not copying the elements into a new array. It is just pointing to that particular location. So if we make some changes in the new arrow, those changes will be reflected back to the original array also. So that will be a view method of copying elements. So actually here what happens, elements are not copied, but instead it is just having a pointer to that particular location from where we are copying. And if we give the copy as command, then it will simply copy. It will not point out, it will not point to the original array, but all the elements are copied to new array and that array will be returned. Okay? Let's see how to do that. The first technique, let's suppose we are initializing an array here, array of element 0 to 70. If I print it, it is giving that array. Now I am slicing this. See, A2 to 5. A2 to 5 means what? 20 to 50, 20 to 50, 20 to 40, sorry, 5 minus 1, right? 5 minus 1 will go. So 20, 30, and 40. So these three elements will be returned to B. Now remember, because we are directly taking elements from A and assigning it to B, it will give directly that particular pointer to these three elements, right? Pointer to these three elements. If I print B here, I can see 20, 30, and 40 is getting printed. Now what I am doing, I am changing the elements. So all the rows and columns by simply colon mentioning was starting from 0 and ending to the length of array. So for all the elements, I want to replace them with 100. So whichever elements were there in B, all the elements will be replaced by 100 using this particular statement. So if I print again the matrix B, it will be the array B, it will be having all the entries as 100. So I can see here all the entries are 100 in array B. But now if I print array A, here you can say earlier it was 0 to 70. Now it has changed. So 0, 10, now 20, 30, and 40 has changed to 100. Right? So this 20, 30, 40 were there. Those were changed to this 100, 100, 100. And the same change gets reflected to A array, which is 100, 100, 100 here also. So this is the method of view actually. That means what? If we retrieve elements using such commands and we assign them to another variable, it's like pointing to the same array of the original location in the memory, right? That is the view by default. But now suppose we don't want view, we don't want original array to be modified, then in that case we use this copy command. So for copying, we can simply write dot copy. Right? Earlier everything is similar. Only if I write dot copy, that implies now it is not pointing to the original matrix or array, but rather it will copy all the elements to the new array and then it will be assigned to B. In that case, if we modify matrix B, that won't get reflected to A. So here I can see this is original array B A, this is original array B. Now when B is modified, then matrix B gets modified, but matrix A remains unchanged. It is the original matrix A. So that is how we can create a copy and use if we want to update the new matrix only. Now conditional selection. Conditional selection means what? Let's suppose we have some array and we want to retrieve the elements which are, let's say, greater than some particular number or less than some particular number, or number which are satisfying some particular condition, let's say some only odd or only even, etc. So if we want to mention such conditions and according to those conditions we want to retrieve the elements, then what is the method? So there we use an intermediate uh, binary or Boolean array. So what is that Boolean array or binary array? If we check the condition, let's say suppose a less than, uh, let's take an array, suppose we'll take an example only. Suppose I am initializing this array np.arange. Okay, what is this a range? In case of Python, we use range function, right? Range function. Let's say if I write range 1, 5, what it will do? It will retrieve, it will return the list of 1 to 4 elements. So 1, 2, 3, 4, these 4 elements will be returned. The same method is used here in NumPy also, using different name, that is called a range, right? So that is like array range. Earlier it was only range for Python in case of list. Here in NumPy it is a range. So here also it works in the similar manner as range only. We can give either only one entry or two entries here. If I mention only one entry here, it will create an array of 0 to 4, 0 to 4 elements. But if I mention two elements, it will start from 10 and it will go up to 20 minus 1, right? So 10 to 19. So it has created that particular array. So this is one array now we have. Now, if I mention this condition, let's say array, now what I'm doing, I'm using this array variable name. Okay. So array ARR mod 2 equal to 0. That means what? I'm checking the condition. If I divide the elements of array by 2 and the remainder is 0, that means what? All the elements are even, right? Remainder is 0 means even elements. So what I'm doing, I'm checking this condition for each element. And wherever condition becomes true, that particular position is marked as true. And if condition becomes false for that element, the position will be marked as false. And accordingly, for each element, true and false are marked, and that complete array is returned by this statement, right? So if I print this particular array, we'll get this array of true and false. You can see for even numbers we are getting true, for odd numbers we are getting false. So this is the Boolean array, right? Now using this Boolean array, we can retrieve the elements from original array, right? We can use this particular array to return. Let's suppose if I mention here, like, let's say x is equal to this, okay? X equal to this. So what we are getting in the X, we are getting that particular true false array. If I just print it here, see, it is the array, right? Now, if I do like this, array of X, array of X. So what it will do, wherever true is there, that particular element is retrieved. Wherever false is there, that element will be skipped. So wherever true is there, that means 10, 12, 14, 16, 18. These elements will be retrieved and all other elements will be skipped. So if I execute this, wait, I have to mention square bracket, wait, not circular. Okay, because we are mentioning the positions there. Right. So I'm getting these elements 10, 12, 14, 16, 18. Right. So in X, we had the true and false elements. So wherever true is there, those elements are retrieved using this particular command now. In the similar fashion, whatever condition we want, we can mention, let's say less than 14, greater than 16, or any condition like that. So here I am mentioning greater than 3, so all the elements are true for that. So everything will be returned. If I mention less than 14, then only for 10, 11, 12, 13, it will be true. For everything else, it will be false. Now that I have taken as the index or position. So that's why it is returning only those elements here, 10, 11, 12, 13. Just like here, we use this array of X. So directly now I am putting this condition only in place of X. That's how we are doing here indexing part. Again, array equal to 5, 15 means whichever element has value of 15, only those elements will be retrieved, right? Similarly here, let's say some new array I have created 20, 23, 23, 25, 26 and so on. So if array 1 is equal to 20, then only that 20 position, 20 elements, wherever it is uh, becoming a true condition, those elements will be retrieved. Even if there are multiple elements of the same value, those will be retrieved here. Right? We can see here, both elements are retrieved. Now, if I want to replace the element, right, in the similar fashion, we can replace, like wherever 20 are there, we want to replace them by 200. So you can do that. Array of 1, where array of 1 has the value 20, replace them by 200. That is the statement. So all the 20 elements which were there are replaced by 200. The similar fashion, let's say wherever 200 are there, replaced by these 400 and 400. Right, so different values. So 400 and 400 are replaced replacing these 200 values. I can mention here different also. Let's see. If I mention 300 here and execute, let me execute from starting. Okay. This is array. Okay, this is array here. Again, execute this and now execute this. Right. So first 200 is replaced by 400 and second 200 is replaced by 300. So like this, individual values having different elements can also be replaced with this condition. In that case, we need to know how many elements are satisfying this condition. Then only we can mention those particular number of values. Otherwise, mention the single value, right? Fine. So now, again, furthermore, operations which can be performed on one dimensional array we can see. So we are initializing a range here using a range array. So array contain the elements from 1 to 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we can square all the elements using simply this operation on the array name, right? So no need to apply for loop. In general, in list, what we do, we can perform similar operations on list also, right? If I mention array and square of that particular list, then list elements will also get squared in the similar manner that we are seeing here for array. So Python list also perform the similar operations. So array square. So all the elements are squared here. Okay. Let's say what is the original array? Original array is 1, 2, 3, 4, 5 up to 9. Then all the elements are squared here. All the elements we are adding 5. So this is the 1 plus 5 is 6, 9 plus 5 is 14. So like this, all the elements are updated with addition of 5. Then cube, right? Power 3 means cube. We are cubing all the elements like this. Again, in addition to that, it's giving the data type. Data type is integer 32. So 32-bit integer it is taking by default. Then mod 2. Mod 2 means what? It's taking only remainder by dividing by 2. Right? Mod 2. We can also give mod 5. Mod 5 means divide by 5 and then take the remainder. So like this, it is taking that particular remainder. We can take mod 3. So anything is fine. Then divide by 2 and take only integer part. Divide by 2 and take only integer part. So like this, we can take that part also. Right. So similarly, we can perform any arithmetic operation on each element by directly applying that particular operation on array. Similarly, some another operations, if we define two arrays, then we can add two arrays directly. So here I am giving the array 2. I can print that array 2 here. So I'll print array 1 so that we can see what arrays they are. So first array is this, second array is this. Range array, okay, array 1 we want to add. Okay. Array 1, if we add, its dimensions are different. Let's see. So it is showing the error, right? Dimensions are different. So array 1 and array 2 have different dimensions. Simply take ARR array here. Let's see these elements. ARR array contain 1, 2, 3, 4, 5, 6, 7, 8, 9. ARR2, which is this A range 3 to 12, it contains these elements. And if I add these two arrays, that means these two arrays, then element wise addition will be stored in this new array. You can see first elements 1 plus 3 is 4, last element 9 plus 11 is 20. Like this, all the corresponding elements are added and a third array gets created here. Similarly, we can multiply the elements. Like 1 multiplied by 3 is 3, 9 multiplied by 11 is 99, and so on. Right? So all individual element wise multiplication will be performed here. In general, what we have, if we have vectors, right? In matrix algebra, if you remember vector algebra, if we have vectors, then multiplication actually is indicating either dot product or cross product. But here, by default, that multiplication is for element wise multiplication. So that's the difference you need to remember. The element wise multiplication will be done using this multiplication operation. For dot and cross, we have dot and cross keywords that we'll see later. In the similar fashion, we can do the division also, right? Just like multiplication. The 1 is getting divided by 3, 9 is getting divided by 11, and so on. All the division elements are stored here. Then operations on two-dimensional array. These are all operations on one-dimensional array that we saw. In the similar fashion, we can perform operations on two-dimensional array also. In case of two-dimensional array, let's suppose this is one array that we are creating. Now again, one more element I am introducing here, function I am introducing, that is reshape. What this reshape do? Whatever first array is there, original array is there, the shape of that array is changed here according to the new dimensions which are mentioned. So like suppose for here, I have array 10, 20, 30, 40. Let me add some more elements. Okay, for now, let's suppose these are the 4 elements, and I'm converting that to 2 by 2 matrix. Okay, so to convert that to 2 by 2 matrix, what I'm doing, dot reshape. So this is the array created. On that array, I am applying dot reshape 2 comma 2. So 2 comma 2 means what? There are 2 rows and 2 columns. So there will be total 4 elements. So these 4 elements will be arranged such that it will have 2 rows and 2 columns, row by row, right? So array 1 will be having 10, 20, 30, 40 elements, and array 2 will be having 1, 2, 3, 4 elements. So I can print here. You can see array 1, and in the similar manner, you can see array 2. If I execute this, you can see 10, 20, 30, 40. This is two-dimensional array created because of reshape, and array 2 is 10, 20, 30, 40. Sorry, array 2 is 1, 2, 3, 4. Two-dimensional array. Now, when we do array 1 plus array 2, it's adding these two matrices element by element. So you can see 10 plus 1 is 11. Lastly, 40 plus 4 is 44, and somewhere in between also element wise addition is done. In a similar manner, multiplication and division can be done. But now, if we want to perform dot operation or cross operation on the matrices, we can use the dot and cross. If you know the dot operation that you have studied in the mathematics, let's say array 1 dot array 2. So what is array 1? Array 1 is 10, 20, 30, 40. Array 2 is 1, 2, 3, 4. If you perform dot operation, what will be the result? What will be the result? What we do? First row, first column, first row, second column, right? The first row here, first row is 10, 20. First column is 1, 3. So multiply those elements. So 10 into 1 is 10, 20 into 30 is 60. 20 into 3 is 60. So 10 plus 60 is 70. So that is the first element that we are getting here, 70. Similarly, first row, second column. First row, second column. How we get that element? Multiply first row of first array with the second column of second array. What is second column here? 2, 4. What is first row? 10, 20. So 10 multiplied by 2 is 20. 20 multiplied by 4 is 80. So 20 plus 80 is 100. That's how we are getting this element 100. So like this, we can perform the dot operation, and that dot operation matrix result is given here. In the similar manner, we can perform cross operation. In cross product, what we remember? A cross B. What happens in cross product? The cross product that we perform in general for matrices, in general in 12th standard, if you remember, you have studied the cross product in between vectors, right? Here we are performing the matrices. So in matrices, what we generally do, we take the element wise row and column, right?
Yes. Matrix
So
multiplication.
those, right, matrix multiplications. So I will mention that in the next session, and then again we'll come back to this cross product, how the result is appearing here.
Okay, sir. Is it different?
Now next,
In
yeah.
this case, is it different from vector product or
Yeah, vector product is different. Vector
Okay.
product is different.
Okay, sir.
Vector product is different. Here it is a matrix multiplication,
Okay, sir.
right? Yeah. Now changing the shape of array. Changing the shape means originally, let's suppose we have 2 by 3 elements. We want to change them as 3 by 2 or 1 by 6 or 6 by 1. So change of shape is possible from one type of shape to another type of shape. Only the condition is the source and destination dimensions which are mentioning. the total size of source and total size of destination should be same. The size mismatch should not be there. If size is mismatched, then that conversion won't occur and it will throw an error. So let's take an example. Suppose we have this 2 by 2 array, right? 1, 2, 3, 4. So there are 2 rows and 2 columns. If I print this array, I can get this as 2 by 2 array. Now shape of this array is 2, 2. That means 2 rows and 2 columns are there. Now what I'm doing, I'm reshaping that. So what is the function? NumPy dot reshape, right? We have already used this earlier also. NumPy dot reshape, the first array is mentioned here and the second dimension is mentioned, right? Second dimension is mentioned. So here what is happening? This A original 2 by 2 array is getting converted to single dimensional array of size 4. So this is single dimensional array of size 4. That's what it is returning. Again, you can see in shape of A, it is giving only 4. So this is one dimensional array. That's why it is giving only 4 to us. In the similar manner, let's suppose if I give third row also. Let's suppose I take 5 and 6 also. Now what is happening? Now array A contains 3 rows and 2 columns. Now shape will be 3, 2. Right? If I print it, we will get the result later. So it is 3 and 2, 3 rows and 2 columns. Now I want to reshape it. Now to reshape, let's, because there are 6 elements, I have to mention 6 in place of 4, right? And if I execute, you can see the result. Now suppose if I mention 4 here, let's see what will happen. Instead of 6, it's throwing an error. Dimension mismatching will be the error. So cannot reshape array of sizes into 4. That's what the dimension mismatch, size mismatch.
Okay.
Right. So that's why correct dimension should be mentioned while reshaping. So I have to mention here as 6. Right. That will be converted to one dimensional 6 array. Now suppose if I mention 2, 3 here, 2, 3, then what will happen? It will be converted to 2 by 3 array. Right. So 2 into 3, there are 6 elements again. Right. So 3 by 2 array is converted to 2 by 3 array. How elements are taken? See the sequence 1, 2, 3, then 4, 5, 6. That means row by row it is going and it is picking up those elements. Right. So that's how it is converted from 3 by 2 to 2 by 3 array. Like this, we can convert to one dimensional or two dimensional array of different size. Transposing array. Right? Transpose operation in linear algebra matrix operation can be done using transpose keyword, that is T only. Right? Just A dot T will give us the transpose matrix. So 1, 2, 3, 4 array is getting converted to 1, 3, 2, 4. That means rows are converted to column and columns are converted to rows. Like this, we are getting the transpose. One more method for the transpose is like using move axis. Move axis means what? We can interchange the axis. Let's say 0th axis is changed to 1 axis, or first axis is changed to second axis, and so on. Axis changing means what? Row and column, if we consider, row is taken as one axis and column is taken as another axis. That means what? Each dimension is taken as axis. First dimension is first axis, second dimension is second axis, 0th dimension is 0th axis. So axis number starts from 0, starting from 0, 1, 2, 3, and so on. There are multiple axes according to the elements whichever are present in the n dimensional array. So here we have only 2 rows and 2 columns. That means there are only 2 dimensions, rows and columns, 2 dimensions. In 0th dimension, there are 2 entries, and in first dimension also there are 2 entries, because this is 2 by 2 array. Now if I make the transpose of that using move axis, how can we perform? See, the array A is defined like this. Array A is 1, 2, 3, 4. Okay, here I can see array A is 1, 2, 3, 4. Now move axis for array A, first entry is source and second entry is destination. This is the syntax. First entry is source and second entry is destination. That means what? 0 entry is moved to -1 entry. -1 means what? Last. right? -1 means last. I can even mention 1 also, no problem here, because there are only 0 and 1 entries only. I can either mention 1 or -1. Both way will get the same result. Or in the reverse also we can do -1 and 1. -1 and 1 will be interchanged like this. So if I execute this part, we'll get the entries shape. And also we can print it. Okay, let me print the matrix also. Print matrix C. So here you can see. Earlier, what is A? A is 1, 2, 3, 4. This is the matrix, original matrix. Now see, when I change 0 axis to -1, -1 to 0, that means what? The rows are changed to columns and columns are changed to rows, right? So these are dimensions. 0 dimension is changed to -1, that is the first dimension, and first dimension is changed to 0 dimension. So rows are changed to columns, columns are changed to rows. That's how we are getting this new entries here.
Sir, if there are multiple axes, then
Let me print
multiple
A
column
here.
or rows.
Yeah, all those will be interchanged. Let me show you. So this is the A matrix here, right? This is matrix A, 1, 2, 3, 4, 5, 6. So 2 rows and 3 columns. So there are 2 elements in first dimension, 0th dimension, and there are 3 elements in the first dimension. Understood? 0th dimension means 2 entries, and first dimension means 3 entries. Now they are interchanged. Now what will happen? It will get reversed. So in the 0th dimension, there will be 3 entries. In the first dimension, there will be 2 entries. So it is interchanged. That's why this move axis implies. I hope you are getting this. We are not mentioning the number of elements in that particular dimension. Right?
Yes.
Dimension means what? Let's say row is one dimension, column is another dimension.
Yes.
We are not mentioning how many elements we want to take in rows, like how many rows or how many columns. We are not mentioning that. We are mentioning the dimension itself. 0 dimension change to one dimension. Even I can mention 1 also here. Okay. If
Yes, sir.
you want to avoid the confusion, you can mention 1 also, no problem. Same result. Right?
Right.
So we are interchanging the dimensions. So in the similar manner, we are getting the results here. So 1, 4, 2, 5, and 3, 6. That is what the transports, right? And the dimension also you can see shape is 3, 3 by 2 matrix. Same result here also we are getting, right? So source 1 is changed to 0 or 0 is changed to 1. They're actually getting interchange only. Right. Next. Again, using the transpose keyword also we can transpose. This is one more method. We have initialize one zeros element and accordingly we are transpose. Just go through this example. Let me know if you understood this. Have you understood the example?
Yes, sir. What is difference between swap axis and move axis?
Okay, swap axis we have discussed. Okay, the move axis is one method. In swap axis, what we are doing? We are interchanging the axis. So we are mentioning axis 1 and axis 2. Those will be interchanged.
Yes, sir.
Here what is happening? Source axis is moved to destination position.
Okay.
Right? So let's suppose, for example, if 0th axis is moved to first destination, then automatically all other dimensions will be shifted to 0. Right? So that will be readjusted automatically.
Okay.
Right. So using swap axis or move axis, we can do that. Again, like if we have more than two number of rows and columns or dimensions, in that case, what we do? So now here I have 4 dimensions mentioned.
Yes, sir.
Right? 4 dimensions. If I print this matrix, it will be a huge matrix actually. How many elements will be there? 3 multiplied by 4 multiplied by 5 multiplied by 6.
Okay.
Right? 3 into 4, 12, 12 into 5, 60, 60 multiplied by 6, 360 elements will be there. If I print this, you can see. So this is the huge matrix.
Okay.
So there are 4 dimensions I'm giving. So I'll just comment it for now. So first dimension have 3 number of elements, second dimension have 4 elements, third 5 elements and 6 elements. So there are total of 3 into 4 into 5 into 6 elements. So what I am doing now, I am just printing the shape. We don't want to print all the matrices again and again. It will be a large, huge. It will be difficult to observe them. But we can print the shape, whether those dimensions are actually getting interchanged to understand that. So if I print the shape of A, you can see it is 3, 4, 5, 6.
Yes.
Now what I'm doing, I'm transposing A. Transposing A means what will happen? All these dimensions get reversed, right? Exact reverse. So 6, 5, 4, 3. You can see using transpose, I am getting 6, 4, 6, 5, 4, 3. Now swap axis. In swap axis, what happens? 0 and minus 1. 0 and minus 1 means what? This 3 and 6 get interchanged. Getting it? 3 and 6 get interchanged, but 4 and 5 will remain as it is. So that's why I can see in swap axis 1, 6 and 3 gets interchanged, but 4 and 5 are as it is.
Okay.
Now to make complete transpose, I have to interchange 4 and 5 also. So that's what I'm doing here. Swap axis 1 and minus 2. So that is interchanging this 5 and 4 also. Right? So 2 times I need to perform that swap axis, then only complete transpose will occur. Either I can do negative indexing or I can do like 0 and 3 and here 1 and 2. That way is also okay, no problem. We'll get the same result. Another move axis. Move axis, in move axis we can perform in 2 ways. Either we can mention all the position of dimensions like 0 dimension, first dimension, second dimension, third dimension. This is source, right? Move axis. So 0 dimension and this is destination. So 0th dimension is changed with -1 dimension. First dimension is changed to -2. Second is changed to -3. Third is changed to -4. Again, instead of negative, if you want to give positive only, then you can mention 3, 2, 1, 0. That is also fine. Getting it?
Yes, sir.
So both will get the same result.
Yes.
So this is one method, like mentioning all the dimensions also we can interchange it. Or mentioning some partial things like 0, 1 and 2 are updated to -1, -2 and -3. Now what is happening? Only 3 is remaining here. Right? So we are not mentioning anything about the third means third dimension. So by default that will be shifted to -0 position, because these 3 are moved to another position. The remaining will be moved to 0 position. Getting it?
Okay, sir.
That
Okay.
is the default shifting. That's why it's not necessary to mention all. Even we can skip that. But sometimes this may appear
We can
confusing
skip
to you.
only one dimension.
Yeah, we can skip only one, not all. Only one. Right? We can skip the second one also. Let's see if we skip this one, then what will happen? In this case, what will happen? 0 will move to -1 means last, and first will move to -2. right? But second and third will remain as it is. Means second and third will go to second and third. So what is second and third here? Second and third has dimensions 4 and 5. So what it will do? It will take, sorry, second and third is 5 and 6. It will do 5, 6, 4, 3 like this. 5, 6, 4, 3. If I execute, you can see 5, 6, 4, 3 it is given. Getting it? Check it again. Earlier it was 3, 4, 5, 6. Right? Now what I am doing? I am shifting zeroth element, zeroth dimension to -1. What is zeroth dimension? 3. 3 I am shifting to last.
Yes.
And 4 I am shifting to -2, means here. So
Yes.
3 is going to last, 4 is going to here. So automatically this 5 and 6 which are remaining, they will be shifted towards left. So 5 and 6 will come here,
Yes, sir.
right? 5
Right.
and 6 will come here, 4 and 3 will go here. So like this, whichever are not mentioned, those will be automatically shifted towards left.
Yes, sir.
Right. So this is one another method. I'll just return back to. So there are different methods to change the row and column positions or different dimension positions, transpose operation. Right? Then joining two or more arrays. Again, concatenation operation, splitting operation, adding existing. There are multiple operations. Fine. So joining two or more arrays and further, we'll see all these operations in the next session. It will again take more than 1 hour to discuss everything. So hopefully in the next session, we'll be completing all the discussion about this NumPy.
Okay, sir. Okay.
So there are, let's see which all operations are remaining. So 2D array, joining multiple 2D, two-dimensional or higher dimensional arrays. Adding elements to existing array. If there is existing array, we want to append some elements at particular position, then how to do that. Deleting few elements from the array or matrix. Then rotating array. This is something very different. This is specifically used for image processing. Like in image, we have different pixels, right?
Yes.
And we want to rotate the particular block of image by 90 degrees, then that can be performed using this rotation operation. It will be like actual rotations, right, in the space.
Yes.
We'll see that in detail. Then further attributes or what all details are available in the NumPy, you can simply print using dir, and all this list is available there. So we are looking at very small thing out of this, whichever are frequently used, but there are many things which are available in NumPy. Right. And furthermore, we can see some more functions like linspace function, minimum, maximum function, argmax, argmin, square root, sin cos functions. Seed function, what seed actually does, random functions, random integers and random floats. Then stacking of two-dimensional array. Stacking means appending one two-dimensional array to another two-dimensional array and combining them in different dimensions.
Okay.
And searching operation on matrices or arrays, right? Or sorting them. So like this, these are different things that we will be seeing in the next session,
Okay.
right? Fine. So any question till this point, whatever you studied till now?
No, sir. I have to practice more. Means,
I hope you have written down all these commands at least.
yes. I have written some.
Okay, fine. So try all of these commands by yourself so that you can understand exactly what it is doing. Right? And remember, all these NumPy commands are very important so that we can apply this going forward in pandas also. In pandas, we are going to use this NumPy arrays.
Yes.
Right? Right. So there will be having different names. We'll see those names, frames we consider there, and how to use them also we'll understand. But NumPy is the basic. On NumPy, this Panda library is developed. So
Okay.
first we need to understand NumPy and then we'll go to the Pandas part.
Okay.
Fine. Fine, then that's it for today. In the next session, we'll see the remaining part of this. Also, we'll see the matrix operation. I'll bring the notepad and pen, and accordingly, I'll explain that.
Will these videos be available?
Yeah, these are available on YouTube. I will be uploading them. First two I have already uploaded.
Okay, sir.
This one
Yes.
also I'll upload in the night. I'll share the link, channel link.
Okay, sir.
Can go through them. Yeah. Fine then.
Thank,
That's it for today. We'll stop here.
thank you, sir.